these practice problems. I think Gigi's actually. All right, so negative 2, 3 is right there, yay? And negative 6, 1 is there. Those are the 2 points that they give you. Now, there is such a line that joins the 2. Do you agree I can make a segment joining the 2? Okay? Are you with me? Okay, now that's not the question. Question says, find the perpendicular bisector to that segment. So if you drew a line that first of all went right perfectly between the 2 through the midpoint of that segment and was at a right angle, this red, that's what we're looking for. We want this. Tracking. Do you remember this from last year? Oh, okay, some yes, some no. Alrighty then. Well, if I want the equation of that red line, it would help if I had a point with a slope. So, how can we come up with a point? A point on the red line. Find a point. What is the point? How can we do you agree that it goes perfectly through the midpoint? And they say use the midpoint formula method. All right, which is to say then that we need to find the midpoint between those 2. How do you find the midpoint between 2 points? You average. You average the x's and average the y's. And when you average, don't you just add the x's together and divide by 2? And add the y's together and divide by 2? And so the midpoint is, what's the sum of the x's divided by 2? Negative 4. And what's the sum of the y's divided by 2? 2. All right? That seems reasonable for the picture. Doesn't that look like negative 4 too? The picture will serve as a check as we go to make sure we're not too far off track. You with me? All right, cool. Now we need a slope. We have to actually find a slope in 2 steps. Find a slope between the points. Between the 2 points. How do we find slope between 2 points? Out for 1, baby. Come on now. Rise over. Run. Change it. Oh, X. Come on now. Rise is changing X. I don't think so. Changing Y over. Changing X. Anybody else not passing it over for? Okay. Changing Y over changing X. When I say change, does that mean subtract the Y's or add the Y's? Subtract is, change is difference. Difference is subtract. So we need to subtract. So I'm talking y2 minus y1 over x2 minus x1. So y2 minus y1 is 1 minus 3 over x2 minus x1 is negative 6 plus 2. What's the slope then that you're getting? Negative 2 over negative 4, which is 1/2. Does that jive with my picture? Now, first of all, is that slope referring to the blue slope or the red slope? It's the blue. It's the slope between the 2 points they give you. Does that look like a 1/2 slope? Seems like, again, like it's going okay. That picture is going. Now, we actually want the perpendicular line. So how do you find perpendicular slope? And perpendicular is opposite and reciprocal. So the opposite reciprocal slope, so that it's going the other way and steeper than the other, is negative 2. Does that seem reasonable to red line slope? Cool? Yeah. All right. Now, this is where we start to learn some practical calculus. In calculus, students always love the old y equals mx plus b, but in calculus you use point slope much, much more frequently. Does anybody remember what point slope form is? Well, it's useful in cases where you have a point and a slope. It's this, y minus y1 equals m times parentheses x minus x1. x1, y1 represents the point that the line goes through, so that's our midpoint. And the slope is the slope of the line you're looking for, which is the red slope, so that's the -2. You follow? So plug into the point slope form, y stays y, and in y1 you put 2. Y minus 2 equals, what's the slope of the red line, not the perpendicular, the original line, but the perpendicular? Is it 1/2 or -2? -2. X stays x minus, what's the x1? -4, so x minus -4 is x plus 4. That is the equation of that line in point slope form. I know students don't like point slope form much at this point, but you will get better and better at it. From that I can see, oh, a point it goes through is 2, -4, or -4, 2, and it has a slope of -2. Last but not least, we need to put our answer in double intercept form. Double intercept form. This is what double intercept form looks like. X over A plus Y over B equals 1. Have you guys got ellipses yet? Does the word ellipse mean anything? From honors, you've seen ellipse, but if you came from Mr. Bell last year, have you seen ellipse?
No.
Okay, cool. It's not that he was supposed to teach, I just can't remember in the book where stuff, so don't think you're in trouble, I just can't remember. All right, well, the deal is this. This, although it feels like, who gives a rip, this is actually really useful practice for ellipse form, because ellipses look a lot like this, but with squares, okay? My point is this. This is what double intercept form looks like of a line. There are at least 4 different forms of an equation of a line, each one having their good points and bad points. I want this one, right? Now the key to this then, to getting from here to here, is first to distribute. So y minus 2 equals -2x minus 8. You follow? All right, now get x's and y's on one side. So 2x plus y is going to be on the left. And on the right, I'm going to move all my constants. So if I add 2 over to get rid of the subtraction 2, then on the right side I have -8 plus 2, which becomes -6. Are you with me? Now we divide to make the 1. What am I talking about to make the 1? Well, you can see that the key characteristic of double intercept form, or one of the keys, is x's and y's on one side, and on the right side is just a stone cold 1. To make that 1, what do? Divide by -6. So I divide by -6, and x over -3 plus y over equals 1. Alrighty then. That's the answer. Let's just be clear what the double intercept form tells us. What does double intercept form tell us? The intercepts, the x and y intercepts here. I know this feels like, who cares, but this is actually the easiest one to graph on. That graphs quicker than all others, including slope-intercept. Because if I know what I'm looking at, then I know that when y is 0, this would go away, and when y is 0, what is x equal to if I solve it? -3. Now, when y is 0, x is -3, isn't that? That's the x-intercept. And when x is 0, this guy goes away. What's y? -6. That's the y-intercept. So if you know double intercept form, you can graph just like that if you know how to use it. if I had x over negative 2 plus y over 8 equals 1, I could say, well, the x-intercept is negative 2, the y-intercept is 8, boom, done. It's way quickest to graph from. Its double intercept form is the best, and it's awesome for ellipses, which we'll talk about later. So that, thankfully, was the hardest one. It's all downhill from here, but that's the process. Did you take good notes so you could do that on your own tonight? Cool. All right. Go to the second box. 7 math books and 3 lit books are on a shelf. How many ways can they be arranged if the math books are kept together and the literature books are kept together? Let's assume they're all different math books and different literature books, so they're not all So, anybody remember this? This kind of feels like you guys need a reminder on this, but I feel like you don't. You should be able to do this. How do you do this? How many ways to arrange the 7 math books? How do you say it? 7 factorial. 7 books, then 6 books for the next spot. 5, 4, 3, 2, 1. So that's 7 factorial for the math. Cool. And then what about the lit books? 3, 2, 1, or 3 factorial. Oops. 1, 2. Lit. Cool. 3 factorial. That's my answer, right? No. Why isn't that good? Yeah, who's to say the math has to come first? It could be the literature first. So you could say or, lit, math, math. So that would be 3 factorial, 7 factorial as well. So in your calculator then, your final answer would be something like 2 times 7 factorial, 3 factorial. Do you remember where the factorial button is in the old calculator? If you do, then you have a leg up on me, because I don't remember. Where is it?
Next to G.
Next to G?
Question mark.
You are correct. It is next to G. Okay, so the factorial is next to G. I imagine it's also in the catalog functions. Okay, let's see. So, yeah. Make sure you have factorial nailed, and 2 times 7 factorial, 3 factorial is probably something pretty big. 7 factorial is 5,000-ish, so 30,000, maybe 60,000-ish. I'm saying ballpark. What do you say? What is it? 60,480? Is that what you said? Okay. Are you with me? Yes. So, if I did the math books first, then the lit books, that would be one arrangement. But they never said it had to be math books first. So all of these possibilities could be switched with putting the lit books first. And so really it's just 2 cases. One with math first, and that would be a huge number of arrangements, and then with lit first. And that's another huge arrangement. So thank you for asking. Does that make sense? Okay, cool. All right. What about number 3? I don't know how you were taught this, but I did it my own way. Let's see how. Do you remember is there a general formula to this idea? The teacher can write 18 words on the board in 3 minutes. The student can write 24 words in 6 minutes. The student began writing for 2 minutes before the teacher begins to help. How long to do a total of 88 words? Now, you've been doing the algebra with this since Algebra 1. They just gave you the givens. What's this first? Would you express that, what's being given? The rate of the teacher is what? 18 words per 3 minutes, or 6 words per minute. Do you agree? What else are you given? The rate of the student is? Talk to me here. 4 words per minute. All right? Time, you're also given. Who works longer, the student or the teacher? Student. How much longer does the student work? So the time of the student is time of the teacher and 2 more than that. Yeah? Okay, that's a whole lot of giving. How long would it take them working together to finish writing a total of 88 words? Now the equation then is what you have to come up with. Come on, Ron, you're so loud. All right, so what do you think? How could I calculate how many words the teacher did? Rate times time. Rate of the teacher, time of the teacher would be total words the teacher did. Words per minute times number of minutes equals words. Check. Plus rate of the student, time of the student. Gives you total words the student did. Equals 88. Cool. Alright. Now let's do some subbing in old facts. I think you all agree that you're not going to be able to solve one equation with 4 unknowns. So you want to get it down to one equation, 1 unknown by substitution. For the rates, we can use 6 and 4. If you want to put the units on, you can, but I don't require it. For the times, they're different times. We would like to substitute so they're the same time. So what do I put in for what? In place of time student, I plug in time teacher plus 2. So this time teacher with the 6 stays. But in place of time student, I replace it with time teacher plus 2, yeah? Alright? Now you have one equation, one unknown. So what'd you get for time of the teacher? 8 minutes. Now let's make sure we answer the question. It says, how long would it take them working together to finish writing a total of 88 words? Is that the same as the time teacher, or is that different? Yeah, the time they spent time working together is the same as the time teacher did, so it is indeed done. 8 minutes. All right. Let's go to number 4. Boy, you've been doing this since Algebra 2. Do you remember how to do these chemical mixture problems? Yes? What's the big idea of these? Before anything goes in, isn't the big idea something like %1 of volume 1? I don't know how you did these, were taught these. This is how I was taught these. Taught to me, people. Did you do something like %1 volume 1 plus or minus, depending on the case? %2 volume 2 equals %3 volume 3. Is that looking familiar-ish? Okay. All right, so in this case, they had 1,000 liters of a solution that was 60% alcohol. Barney needed a solution that was 45% alcohol, so he needed to take some of the alcohol away. How many liters of alcohol had to be extracted so the solution was 45%? Okay, so in this first case, what do we have, percent and volume-wise? 60. We're starting with 60%. Do you use 60 or 0.6? I don't care which. 60, okay? And what was the volume of the 60%? Do you know it, or is it unknown? It is 1,000. That was known. 1,000 liters of 60% was what it started with, yeah? Okay? What are we adding or subtracting? Where's the 45 go? Here, or is it the end result here? The end result is 45%. Okay, so that's what we're trying to get to. Do you want to jump to that now, or do the second part? Let's jump to actually, let's keep going here. So we want to extract, it says we're going to extract pure alcohol so that the percentage of alcohol is less. So are we going to add or subtract? Subtract. If it's pure alcohol, then 100% pure alcohol And what's the volume of pure alcohol that's going to be extracted? We don't know. How many liters of alcohol should be extracted? That is the unknown. We do not know. Yay? Okay? I'll call it VA, whatever you want to call it. Equals what? 45 of V3? We don't know that either. But we don't want two variables. What do we call that last volume? X plus 1,000 or 1,000 minus X or X minus 1,000? 1,000 minus whatever we take away would be the volume of the last. Alrighty, after that it's go time. 60,000 minus 100x equals 45,000. It's 45x. Add 100 over 55x. Subtract 45,000. 15,000. X is 15,000 over 55. That's 11 over 3,000. That's not coming out pretty. Oh well, life is ugly, I guess. 2. I'm getting something kind of funky.
You left it? It's a fraction last year.
You did?
Yeah.
Okay. Seems like liters should be decimals, but okay, I'm down. Fraction is fine. All right, X is 3,011ths. What are the units on that? Was it? Liters. All right. Okay, so by taking roughly 270 liters of alcohol out, then it's less alcohol over less total. You're down to 45%. Okay, that makes sense. All right, are we good? Questions? All right, 5. I don't know why these is 5 question mark? Why is this hard? Okay, is this symmetric about the x-axis, the y-axis, and the origin? Hey, where's the mirror, if you like? So this is the y-axis, yeah? What about B? X. Okay. Let's just throw in, they didn't give you an origin case. Can you give me any graph that's symmetrical about the origin? Circle is true. It's not a function, but that's true. What about a power? X to what power? Cube, yeah, x cubed is symmetric about the origin. The idea is if you draw, it's point symmetry. So if you draw through the point of symmetry on either side, the distance to the curve is always the same on either side, no matter where you draw. Cool. Okay, tangent is also. Let's go to 6. A should be good. You do A, and we'll do B together. Give me radians here. Pi over 7? What is it? Pi over 3, 6, 4, 2? 3. Pi over 3. Okay. The other one requires a little more. This is not a calculator problem. So do not do the arctangent or just type it in as you see it. Instead, it's a draw question. First, draw this. Draw first. Then sine. So I'm going to do the sine of something in a second, but let's first draw the picture. What quadrant is arctangent in, or what quadrants is arctangent? First and fourth. Okay, so don't go in the lava zone. Is it first or fourth for this problem? Fourth, because it's negative. Is 3 the, first of all, do I draw a triangle like this with the y-axis? Or no, that's crazy, you never draw with the y-axis, it's always with the x-axis. Always with the x-axis. Okay, what are the sides, negative 3 and 4, where are they? Toa. SOHCAHTOA. Toa. Negative 3 is opposite, and adjacent is 4. Are you tracking? Find the hypotenuse by Pythagorean theorem. What is it? 5, or by Pythagorean triple if you like. All right. Now, we've got this picture, but the question wasn't, hey, draw this cute picture. It was, find the sign for that picture. What's the sign? Sine is opposite over hypotenuse, so you say negative 3/5. You do not need a calculator, but if you wanted to check it with your calculator, you could. You could do the arctangent of negative 3/4, see what angle it gives, and then sine of that, you'll see it's negative 3/5. Okay, cool. That is all I have questions on. Now, remember others? Okay, thanks. All right. We felt like the other ones, we didn't know if you would need help on those or not. What do you feel like on 7, 8, 9, and 10? You feel cool there, or no, those are bad? Okay, if you feel good with those, then you do not have to do them. Here's your homework. Turn it over to side B. And by it, I mean the test sheet. Okay? Your homework is doing similar questions on side B, and which we did not practice. I will explain when everybody stops it. Okay. Is that 2 or 3 days? No. All right. So, here's the deal. Anything with a star is calculator active. You may use a calculator. The front side of problem set S is from test 12B. So make sure you're on the B side of the test. Are you on the B side of the test? Okay. 1 through 10, hopefully 1 through 6 should go well. For Pete's sake, we just did one just like it, so use that as a guide. Notes are meant to guide you. The back, those are more of a reference to your old packets. You know, you still have that packet of old Saxon tests. You'll need that for the back side, all right? This whole thing is your homework. It is due tomorrow, and you have 17 minutes to work. Let me know if I can help you. Yes? Just for lunch. Yeah. No, Bobby doesn't know about that, so you know. It's not just saying it. All right. here. And then goes to get X is on one side and constants on the other. So the minus x1 y over the square is the so when we say y minus y stays y, but y1 is what is the perpendicular slope, so we can and then distribute x's and y's on the